Now, let's revise. What did you say? We say that this is the graph for sine, cosine, and tan. And we said that the domain for the sine will be from negative pi over 2 up to pi over 2, and they are included. And the range will be from negative 1 to 1. The cosine, its domain is from 0 to pi, and they are included. And the range is from negative 1 to 1. And for the tan, it's from negative pi over 2 to pi over 2, and its range is any real number. And we talk about the other three basic identities, which is cosecant, secant, and cotangent functions. The cosecant, as I told you, it's 1 over sine. The secant is 1 over cosine, and the cotan is 1 over tan. These are the three other basic functions. So by now we have sine, cosine, tan, cosecant, secant, and cotan. So we call them the reciprocal identities. That's me. The cosecant is 1 over sine, and the sine will be 1 over cosecant. The secant is 1 over cosine, and the cosine is 1 over secant. The tan is 1 over cotan, and the cotan is 1 over tan. These 6 identities, we call them reciprocal identities. Now, be careful when you want to find their domain. As I told you, when you have x minus 2 over x, you will tell me all the real numbers except 0. And here, you will tell me that the domain of the numbers except when the sign or when the denominator here is 0. And we have another identities, we call them tangent identities. Now, we know that, I don't know if we take them before or no, that the tan, you can find it as sine over cosine. That means the sine for any angle over its cosine give you tan. And from the reciprocal identities, we know that the tan is 1 over cotan. So since the tan is 1 over cotan, so the cotan will be 1 over tan. Or can say 1 over sine over cosine. So you will say that the cotan is cosine over sine, which is the reciprocal of 1 over sine over cosine. So the tan is sine over cosine, and the cotan is cosine over sine. These are here the identities for the reciprocal, which we call them reciprocal and tangent. Remember that when these are you must need them, because sometimes you need to solve an equation. Sometimes you need to verify the identity. Sometimes you need to find the domain. So you must know them. You must know the domain and the range for the three basic identities in order to solve. So I will repeat them here. These are the 3 of the 6 basic identities. Cosecant is 1 over sine, and sine is 1 over cosecant. Secant is 1 over cosine. Cosine is 1 over secant. Tan is 1 over cotan, and cotan is 1 over tan. If you come back to the tangent identity, you have to know that tan is sine over cosine, and cotan is cosine over sine. These are very important. And the other important things, which are they? The domain and the range for the 3 basics, for the cosine, for the sine, and for the tan. These are very important. Now,
so teacher?
Yes.
So teacher, the secant, it's just like the opposite of the cosine. And we can say it's cosine equal 1 over secant. Like they are both
Yes.
opposites.
Yes, they are reciprocal to each other. Okay, now. Let's start now with this problem here, find the domain of the validity if you have it like cosine is 1 over secant. Here now, I want to know, if you know that cosine is 1 over secant, what is the domain will be? The first step, you have to draw the cosine. And I give you today two ways to find the domain. The first way, you have to draw the cosine, as you know. Then, since the cosine of the secant is a reciprocal of cosine, from here we have it as cosine is 1 over secant. And secant is 1 over cosine. So if I need to graph secant, okay, I just remember that it is the reciprocal of cosine. So I have to draw the cosine first. That's, I told you, it starts from 0 angle with 1 up to, and at pi it is -1, at pi over 2 it's 0, and so on. You have to graph the cosine, the graph of the cosine. And then you have to remember, how can we draw the reciprocal of any function? Let's remember here. Let's take the simplest one that we know it before. If you want to write or graph the reciprocal of any functions like y over x is a linear. And you draw it, you make it like this linear function here. That's it is increased. Now, and its domain is all the real numbers and its range all the real numbers. But if you want to draw now its reciprocal, what is the reciprocal will be? It is x. So the reciprocal will be 1 over x. So that's mean you have to make the same domain. But here, since the denominator, there is a denominator. So the excluded value will be at the zeros of the denominator. Where is the zeros of the denominator? At which point let x equal 0? When x is 0. Here, you need to find the domain. So the domain for the reciprocal function will be all real numbers except the excluded value. These we took it in grade 8. What are the excluded value? How did you find the excluded value?
For this one, x cannot equal 0.
Yeah,
So by
it's the values that make the denominator 0.
Exactly, the zeros of the denominator. So you come back to the denominator here, you will see where is the, which number make the denominator is 0. Which is 0. So you will say here that the domain for this one will be all real numbers except a 0. That's me. Okay, how I graph it now. Since it's 0, so that's mean I have both of the vertical and the horizontal as from here. Now, you know that I remind you that if you have it as 1 over x minus b plus c, this will be the vertical and this be the horizontal asymptotes. Okay, and value of k, if it is greater than 0 or if it is positive, I have to be on the first and third quadrant, and if k is less than 0, I have to be in the second and the fourth quadrant. You do remember this? This is from grade 8.
What is the vertical and
the B is vertical.
This was from this year. The reciprocal function was from this year, right?
Yeah, I will talk about it, and but you take about it in details in grade 8. You talk about it, yes, in chapter 8 here too.
Are you talking about 1 over x minus b?
Here, the main formula is 1 over x minus b plus c. So this b here, it told me about the vertical asymptotes, and c about the horizontal asymptotes. So if you look at 1 over x here, Where's the vertical asymptotes? Or 1 over x from the function. Where's the, it's like 1 over x minus 0. So where's the vertical asymptotes? At
the y-axis.
Yes, at x equals 0. And where's the horizontal asymptotes?
It's y equals 0.
The horizontal at y equals 0. So this is here. Sorry. This is here will be the vertical and the horizontal asymptotes. And then you need now to graph it. Since now we are talking about reciprocal, and as I told you, this K here, it told me that I am talking about first and third quadrant. This told me here about the vertical and horizontal asymptotes. So to graph the curve, it's come like this. So this is here for 1 over x. This come like a curves. But for these curves, it's mean that here you are in quadrant 1 and quadrant 3. When you draw its reciprocal, be careful that do not pass at 0, because 0 is the excluded value. So when you draw it here, you draw it as a curve, but at not, you don't draw it at x equals 0. This is here how to draw the reciprocal of the function. Yes.
Teacher, so the domain here for the second graph is the x-axis?
Except 0.
So the domain can be 0.
Yes, it can be real, but except 0.
Okay.
Okay. Hello, this is here for the functions, for the linear, for the quadratic. Now let's come back to talk about.
But teacher, only in case if we have a fraction. If we don't, like if we have y equal x, it's okay to have 0, right?
Y, yes. If there's no denominator, there isn't any problem. If the problem will be if you have a rational expression such as x minus 4. This is here. If you want to find the domain, you cannot put a negative number, because the domain for any rational number must be greater than 0. And this is here, you must take care about it. And for the denominator of like 1 over x minus 4, here you cannot say all real numbers. Like what also? I think that for the absolute value of x, here it's like you be careful, you have to take careful about its domain and so on. In this, some of the expressions here, you cannot say that or real value. So if you have a denominator, you have to find the excluded value.
Teacher, the absolute x, it can be 0, right?
Yes, it can be 0, yes.
And also negative, it's okay, because it will be then positive.
Yeah, but yes, for them, yeah, but the range, it must be positive.
Okay.
Now let's come back to the trigonometric functions. So what did I mean? I told you about the reciprocal in order here to draw the reciprocal of the cosine, because we know that the reciprocal of cosine is secant. So I told you here now that the secant is 1 over cosine. So as I told you before, you have to find the asymptotes, the vertical asymptotes or the horizontal asymptotes for the original function, the identity. Oh, sorry, for the you have to find, I'm sorry, you have to find the asymptotes for the reciprocal in order to draw it. Now here, we have the same. For secant, it is 1 over cosine. So to find the vertical asymptotes, you need to find where is the excluded value, as I told you before. Now here, where is the excluded value will be?
0.
At, not 0, at the points that makes cosine of the angle is 0. In which angles that their cosine is 0?
It's 0.
90
90.
cosine.
أيوة.
90
Bravo.
and
By.
270.
Bravo.
It's pi over
Pi
2.
over 2. Oh, sorry. This is pi over 2.
And 3 pi over 2.
So at. Taman, how did you know them here? From the graph now. I know, let's say that we don't know the graph. We don't know the table. Now look at the points where they intercept the x-axis. They are at pi over 2, 3 pi over 2, and this one I think 7 pi over 2. This point here, negative pi over 2, negative 3 pi over 2. These are all the vertical asymptotes that make the cosine is 0. This is the first step. You have to, in order to draw the secant, you have to find the reciprocal, the zeros of the denominator in order to find the vertical asymptotes. Okay?
Teacher, what do you mean that we find the zeros of the denominator?
Okay. I will repeat here. Now, you need to find the vertical asymptotes. Remember that if you have it like 1 over x minus b plus c, this b here is the vertical asymptotes. And this c here is a horizontal. Okay? Now, so in order to find the vertical asymptotes, you have to find the excluded value. And if you need to find the excluded value, you have to find the zeros of the denominator. How did you find the zero of the denominator? You will bring the denominator. Where's the denominator? It is cosine. You will ask the cosine. Yeah, cosine. At which angles you are 0? Cosine, tell me that I am 0 at pi over 2, at 3 pi over 2, at 5 pi over 2, at 7 pi over 2, at negative pi over 2, at negative 3 pi over 2, and so on. All of these angles, if you find my cosine on them, you will find that they am 0. So all of these numbers will be the excluded value. And all of these numbers will have the vertical asymptotes, as you see here.
Okay, thank you, teacher.
Yeah. And this is the first step. Now, after we draw the vertical asymptotes, you have to draw the secant now. In order to draw the secant, you have to find them like I want to draw the curve and like a curve here, but don't intercept the asymptotes. So let's come like this, like this. And so on. This is now the graph, the red for the secant. So what is the domain will be for the red graph now, or for the red curves?
All real numbers?
From
There's an exception.
pi over 2, there are asymptotes.
Yeah, so what you have to do?
So from pi over 2 to 3 pi over 2.
What about the other numbers?
Not included.
So can you say it is all the real numbers except pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2?
Yeah.
Yeah, that is
you have, yeah, so you have to say that it is the all real numbers except these values. Now, how can I rewrite these values? Here, you have to know something. In angles, you have to say odd multiple or even multiple. Like, look at here. The number is 1, 3, 5, 7, -1, -3. So are these numbers are odd or even?
Odd.
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 Got it? 1, 3, 5, 7, and so on. They are odd. So you have to say that all real numbers except n times pi over 2, where is n? Where is n? Is odd. Or in other words, you can say that except the odd multiples of pi over 2.
Teacher, and we can say like خلاص all real numbers except this.
Yes.
But teacher, how do you find these numbers? Like, okay, I know that you find it by this line, but like how we can specify it? Or you are going to give it to us?
No, I will not give it for you. Here, you know that at pi over 2, from the table that I give it in the last week, give it to you, that the sine, or sorry, the cosine of 0 is 1. For pi over 2 is 0. So that's mean that here, just 1 second, please. So you know that at 0 is 1. You have to know the graph. This is the cosine. It starts from 1, so this is for the cosine. So then you ask yourself, here it is 0. Here pi over 2. Here negative pi. Here it's wait just 1 second, please. Here it's 3 pi over 2. And then here it is 2 pi. So I mean, like, from this from here up to here, you draw that it is from 0 to 1. Then it's repeat itself. Here 0. Then how did you remember that? How did you go in unit circle? You start for the first round, then you go for the second round. For the second round, you have a new angles, but they have the same measurement of the cosine and sine. So if here you have it as 0, here it's repeat itself. But now you have to, did you remember that when I told you before, here you have 0, 90, 180, and 270.
Yeah.
And if you finish it, you have to start now with 360. Then 360 plus 90, which is
450.
Plus 90, 540. Plus 90,
660.
How?
630.
630. And here 720. So that's mean at cosine of 450 will be the same as it will be the same cosine of 90, which is here. This is here 450, I mean. And 630 have the same cosine of 270, which is here. So that's will it repeats itself.
Okay, teacher, thank you.
Do you understand it well?
Yeah, teacher, thank you.
Okay. So now this is the first way. You have to know it if you have the graph. Now, if you don't have the graph, or if you don't need to draw the asymptotes and continue, just say that the cosine is 1 over secant. And the secant is 1 over cosine. So in order to find the domain here, just ask yourself, what is the numbers without having this graph, okay? Ask yourself now, what is the number that their cosine of 0? By the way, if you use the calculator will not help you. Because if you know it by the calculator, if you try by the calculator, try as cosine inverse of 0. If you try it, they give you that it is pi over 2 only. But they don't give you 3 pi over 2 and 5 pi over 2. They give you only pi over 2. So you have to know them. So you ask yourself now, when I want to find the domain, and since they are written as a numerator over denominator, so I have to look at the zeros of the denominator. The zeros of the denominator where the cosine is 0. Where is the cosine of 0? At pi over 2. Now from here, I know that at is pi over 2 and 3 pi over 2. Which do you know them from the table rows? That at pi over 2 and 3 pi over 2, their cosine is 0.
Yeah.
Yeah. So if you noticed here that the number is odd, so I will continue using the odd numbers. Yani 1, 3, 5, 7, 9, and 11. All of these, their cosines are 0.
Okay, teacher, you mean like we will continue as 7, then 9,
Yeah,
then
all
11, then
bravo.
13.
Yes, that's it.
And if it was like, for example, 2 pi, it will be 2 pi, then 4 pi, then 6 pi, like that?
Yes. The odd, and they
Okay.
could be odd or even.
Okay.
So from my knowledge from the table that I have, I know that pi over 2 and 3 pi over 2 are 0. So I can continue. So what I have to do here, I have to say that the domain will be all the real numbers except these values. I will not write all of them to the teacher. I will write that except on odd multiples of pi over 2, or you can say except n times pi over 2, whereas n is odd. Is it clear now?
What did you say the last thing?
You can say it like here in all. No, sorry. You can say like it's all real numbers except odd multiples
Of pi over 2.
Or you can say all real numbers except n pi over 2, where n is odd.
Okay.
This is another way. Is it clear?
Yeah.
Now,
Yes.
what's the time now? Okay. Now let's have another example now. What is the domain of sine is 1 over cosecant? Sine is 1 over cosecant. Now I bring the shapes for you here. This is for sine. And sine is 1 over cosecant. And cosecant is 1 over sine. So if you want to find the domain now, how it will be? It will be all the real numbers
Except the one that make the sign 0.
exactly, except what now? I want now to go to the denominator. Where is my denominator? It is sine. Now, after that, I will ask the sine. Yes, sine. At which values you are 0?
It's 0, 2, and
0,
180,
0, pi,
and 360.
2 pi, negative pi.
And
Look at them from here, the table. Look at the graph here. 0
All the
by 2 by,
pi,
sorry?
all the multiples, like the domain is all the
Exactly.
multiples, all real
All the
numbers except the
multiples of
multiples.
even.
So as you see here, we have a 0, 1 by, 2 by, 3 by, negative by, negative 2 by. So all the real numbers except what? Multiples
Of even.
of by. Yeah, you have to say
No,
multiples of by or
even the
by over
odd.
2.
Wait, what?
Because we have 0, we have 1, and then we have 1 and we have 2. So it could be odd and even, but not for by over 2, for only by. We have 0 by, 1 by, 2 by, 3 by, negative by, negative 2 by. So I cannot say only the odd multiples of by, and I cannot say only the even odd multiples of by, or the all multiples of by.
Okay, because like teacher, we have 0 by, 1 by, so yeah, all of them.
Yes. Is it clear? This is
teacher, can't I say like all the real numbers except all the real numbers?
how?
Because teacher, like see, like the multiple of by,
multiples
they are
of
all
by,
multiples of
I
by.
mean, no, multiples of by, I mean 0, I mean by, I mean 2 by. But what about by over 2? 3 by over 2? I cannot cancel them.
Oh, okay.
Okay, so here you can draw the graph of the sine. Then you will ask yourself, where's the asymptotes? And at the asymptotes will be the excluded value. So you will write that it's all real numbers except the multiples of by.
But teacher, negative 3 over 2 by, isn't it a multiple of by?
No, it's a multiple of by over 2.
Ah, okay.
Okay.
Yeah.
Now,
I think we just need to memorize the graph that you show it for us the first period, because it's really important for this.
yes, yeah, exactly. Now, let's now talk about the second part of our lesson, or part 2, we can say. We have listed many parts. That's how to verify an identity using the basic identities, and which I love them so much, and which I have bring hard questions from them. Here now,
No, teacher, please no.
here, for this one, each example is an case. Did you remember, like in chapter 9, like each numbers have a formula or have an it could be series, it could be a sequence. Do you remember the arithmetic or geometric or blah blah blah, all these things? Each
Yes.
numbers have here now, each equation you have to think how to prove it. You will not have you have identities, but you have to think which identities I have to use to prove that that if I multiply sine times secant, I get tan.
Teacher, can you repeat what you say?
Let's say I will first stop here today. Okay, tomorrow I will repeat them.
Okay, teacher. So what we need to know
This
today
is what is coming with us in the finals, right?
Yes, this will be for the finals.
Allah yarhamna.
Okay, teacher. Allah yarhamna.
يلا توكلوا خير. باي باي.